We're looking at this idea that quadrilaterals either have two pairs of parallel sides or they have one pair of parallel sides. If there are two pairs of parallel sides, that is going to be called a parallelogram. If there is one pair of parallel sides, that is going to be called a trapezoid. Now we're thinking about this exclusive definition. Exactly one pair of parallel sides. So as long as there are two sides of the quadrilateral parallel, and actually it doesn't even matter if the lines look parallel or not. Well, could do better than that. Okay, as long as we're told they're parallel, we have to consider them to be parallel. So don't forget that trapezoids are what we're going to call truncated triangles. So if you take a triangle and you cut a corner off with a line segment parallel to one of the sides of the triangle, then you get a trapezoid. So if I truncate this triangle, what I'm left with is a trapezoid. Now, isosceles trapezoids are a main focus. Ooh, no. And they were once isosceles triangles. One of the theorems that we have, and that we'll explore a little more, is that the base angles are going to be congruent of an isosceles trapezoid. So that's really something that you're going to want to remember, make a note of. Okay, if we had a right triangle and we truncated the triangle, we would have a right trapezoid. So a trapezoid is a quadrilateral exactly one pair of parallel sides. The parallel sides are called bases. The non-parallel sides are called legs. Okay. And then the bases, I don't know. The bases, I think the main thing that you're gonna have to think about is that with any trapezoid, you have the bases being actually two parallel lines, right? And then the rest of the trapezoid is formed because you have two transversals cutting those two, I don't know, parallel lines, right? So you kind of have this idea of two transversals cutting parallel lines, and then you get this trapezoid situation. All right, so there's a set of theorems that have specifically to do with isosceles trapezoids. Okay, so if you're told, let's say if a trapezoid is isosceles. So if you're told that there's a trapezoid and it's isosceles, so the legs are congruent, then you can deduce that the base angles are congruent. Now this is something like you have to think about just a little bit more in depth, because the base angles are angles that are on the base of the trapezoid. Okay, and I'm hesitating because I have to figure out how I'm going to explain this, right? So P, Q, R, S, right? So here, since PQ is parallel to RS, then PQ and RS are the bases. Okay. Now the base angles are PQR and so that would be PQR and QPS. QPS are base angles. And then the other set of base angles are on the other base. So angle QRS and angle RSP are base angles. So if a trapezoid has isosceles, that means the legs are congruent. You can deduce that the base angles are congruent. And then the converse is also true. If the base angles of a trapezoid are congruent, then the trapezoid is isosceles.